Um, Hello everyone. So I'm going to be taking you through this part of language models, and I'm going to be starting with what they call preliminaries, which are basically the primitives that are required to evaluate a language model. So these primitives include scenarios, adaptations, and metrics. So I'm going to be taking you through one by one as we continue. So let us start with scenarios. So scenarios is basically what we want our model to do. So if you want your model to be summarize a question, if you want your model to be answering some questions, so basically those are what they call scenarios. So while practical use cases for language models involve other factors, we optimize scenarios through a list of instances divided into training and one or more set testing sets. So they are showing you that if you're training a model, you're supposed to split the data into training and to one or test sets. So for every scenario, it has to have an input. Then for every instances, for example, something that the model is going to be doing. So that instance is supposed to be having a string and a list of references. So let me show you that on the next screen, what I'm talking about. So this is basically what I'm talking about. So this is a scenario which has a question and a reference which includes all the answers that are specifically going to be dedicated to that question. So the model is supposed to pick out one correct answer out of the answers in the reference. So basically, this is an example of what a scenario is. So after scenario, let us go to adaptations, whereby this is just a procedure to transform a language model along with training instances into a system that can make predictions on new instances. So the model that was being trained that it's going to be transformed into a system, and this system will be making predictions depending on the new instances or the new data that will be brought into place. So examples of the things we do during adaptations, they include prompting, lightweight, fine-tuning, and fine-tuning. So basically prompting is when we just basically give prompts into or questions into the model, and the model gives us responses. And lightweight fine tuning, this is basically when we make minor adjustments to the model that is based on new data. So here we are making just minor adjustments. Then fine tuning, we are making significant adjustments. But these adjustments are made when you're introducing new instances on your data. So here, let me show you an example of adaptations whereby here at my left, there are some questions and the references. So this side, they are showing you that they are transforming this model that was trained on this data into a system that will be able to predict. If you give it a question, it predicts. So adaptation is basically transforming a model which was trained into a system that can predict the outputs depending on the new test instances that will be brought. So after adaptations, let us go to the metrics. These are just used to evaluate the instances for each scenario. So they evaluate to see how well the model is working. So some of these metrics here, according to the paper, they used 7 metrics, but I've just given you examples of some of the metrics that were used. Those are the robustness, fairness, accuracy, inference runtime, toxicity, bias, such metrics were used. So this is an example of a scenario, because we said earlier that a scenario consists of a task, a domain, and a language. So the task is basically what you want your model to do, basically what you want the model to give you. Then a domain is basically the place or the situation in which the model is supposed to give you your answer. Then the language is the language that the model is going to be using provide the answer, which can be any language, which is either English or any other language. So the core scenarios, We taxonomize scenarios as shown in the slides above. So there I was showing you that the table above was including tasks, which were question answering and summarization and others. Then which it also had a domain. The domain was basically the three concepts that are consisted in a domain, which are what, who, and when. So basically, for each and every domain, you have to know what basically the model is going to be doing, who, who are the users, then when, as in when is that scenario you bringing in, who are the people that wrote in this scenario. So that is what they call a domain. Now, the next slide, we're going to be showing some tasks. So the tasks, as you can see, we have question answering, summarization, text command. So there are many tasks, as you can see, that these tasks can be added up with domains to make what we call scenarios. So for the domain, as I said earlier, the domain consists of the three concepts. Those are the what, the type of text which captures the subject and the register difference. Then the when, this is when the text was created. Then the who generated the data, or who the data is all about. So that is basically what the domain consists. As we go on further, let us start going through some of the tasks one by one, the tasks that were provided in this particular paper. So the first one is question answering. So question answering is basically you're giving a model a question and it's supposed to give you answers. So this is basically based on three things. That is language understanding. The model should be able to understand the language in which you have asked the question. The integration of knowledge, it should be able to integrate the knowledge so that it gives you a convenient response. Then reasoning. The model is supposed to be good enough to reason and know the response. Then this is the problem setting of question answering. So here it's just easy that we give a model question. For example, who was the painter of the Mona Lisa? Okay, where was the painter of Mona Lisa born? So the task is to predict the correct answer, which is, we all know that the painter was born in Italy. So the format of question answering may have some variations in the open book or in the reading comprehension settings. Additional context to refer to, such as supporting documents. So down there, these are some of the databases that are used. These are some of the databases that are used while carrying out question answering tasks. And here, this is an example of question answering task whereby they give a model a question and it has references on which it's going to get the answer from. So another task is information retrieval. This mainly focuses on the passages. Basically it focuses on retrieving information. So basically for information retrieval, the model is given a corpus. Corpus is like a dataset that includes a lot of passages, or it includes a big set of dataset. So when this corpus is very large, you consider only ranking top K passages. So when you ask a model a question, the model is supposed to rank the passages depending on the passage which includes the answer. So they rank them to a top value. For example, if K is 5, so they rank them to top 5 passages. So among those top 5 passages, the answer to the question is supposed to be among the 5 that are ranked. So this is the problem setting of how information retrieval works. So a given passage CI and a query queue. So given the passage CI, that implies that is like a question to a model. So they want the model to retrieve some data. We ask the model whether the passage contains an answer to the query. So the passage you have provided and a query, so the passage should contain an answer to the query. So if a model answers yes, then that passage has a high probability of having the answer. So it's ranked at high. Its ranking is high. So when they ask a model whether a passage consists of an answer and the model says no, then that implies that that passage has a low probability of including the answer to a certain information retrieval question. So basically, that's the problem setting. And some of the data sets that I used, they are MS Marco and Trek 2019, as I've shown you down there. Then summarization is next. So to effectively summarize, system must identify and yield the core relevant and information content in the source document. So basically, summarization is like a process of minimizing some text. So if it's big, you want to summarize your text. But this one focuses on only important information in the passage or in the document you are providing. So it removes the irrelevant information in order to avoid redundancy so that the user that asks the model to summarize gets only information that is fully summarized but has the same meaning as the original document. So this is the problem setting, summarization. So to evaluate the model performance, the model generated summary is compared against the human author reference summary using automated metrics for overlay quality, and the following are used. So here they compare the summarized document from the model and that is summarized by a human being, and they compare them using faithfulness and exactness. Faithfulness is basically refers to whether all the information in the model summary is supported by the article. So whatever the model has summarized, it's supposed to be supported by the document or the article that was input into the model. That's what they call faithfulness. Then exactness refers to the extent to which model summaries involving copying from the input document. So we evaluate the extent to which this model has copied the same information from the document that was given. And some of the data sets that are used are this CNN and the XSN. Then we go to sentiment analysis. This refers to the emotional tone or attitude expressed in a piece of text. So the model is provided with a piece of text, and its role is basically to state either positive or negative to show that sentiment analysis or the tone that is behind that piece of text. So the data sets used here are IB, IMB, IMDB, and some other data sets that were not basically mentioned in the paper. Then this is an example of a sentiment analysis. So they insert or they prove the question to the work a person to a model. So the model basically has to predict whether positive or negative, depending on the attitude that is behind the question that was asked or the information that was put into the model. So toxicity detection, this is basically we identify the harmful or the toxicity behind a particular passage or information or document that was fed into the model. So the problem setting of toxicity detection is that it's like sentiment analysis. So basically they give a model a text and the model basically has to predict whether it's toxic or not. So it also provides binary labels, which are either true or false. So here down here, it's an example of a toxicity detection question that was put into the model, and it was given the reference, which I have already told you is supposed to be binary, which is either true or false. So lastly, go with sentiment, go with miscellaneous text classification. So this is basically like both toxicity detection and sentiment analysis, whereby the model is given some labels and it's given the text. So this text is supposed to categorize it into either one of the labels that it was provided with. So, and the data sets used is the rough and some other data sets. So that's it for me, guys. We'll meet next time. Thanks for listening.